Hello, Algebra I. Today we are going to be continuing our conversation of slope, and we will be working through pages 9 and 10 in your packets. So before we get into the packet work exactly, we're going to start by reviewing what is slope. So slope is described as the equation mx plus b. This should be review from last time and past years that you've had in math. Our m represents our slope, and our b represents our y-intercept. So again, the y-intercept is where the line crosses the y-axis. And then our slope is described as the horizontal and vertical change from one point to another. Again, the way that we're really going to talk about slope is rise over run. So again, when we talk about rise over run, that means we're taking y2 and we subtract y1, then we take x2, subtract x1. So y2 minus y1 talks about our vertical change. X2 minus x1 describes our horizontal change. To kind of see what this looks like in a graph, again, this is kind of mostly review from what we've done the past few classes. We're going to pretend that that actually hits the line. When I have 2 points on a graph, I'm going to make a slope triangle. The distance that I travel up and down is how I describe my rise. The distance that I travel left and right will describe my run. So this is some kind of technical stuff to talk about review-wise. When we see our equation of y equals mx plus b, sometimes we will see it called slope-intercept form. It's called slope-intercept form because these are the two pieces that we use in our equation. M being slope, and again, B being the y-intercept, which is why we call it slope-intercept form. It's even in the correct order that we need our letters to be in. This is where we are going to move into page 9 of your packets. So, for 1 through 3, we are told to write the equation of the line in slope-intercept form, which means we're writing it as y equals mx plus b. So, in number 1, we can see that I'm given a specific point, and I have what m is equal to. So, from here, I have to kind of figure out, using the equation, how in the world do I come up with y equals mx plus b when I really don't even have a b that I can go off of? I'm going to jump over to a different slide just so I can see a little bit more work that I'll have to do for this one. So, again, our equation is y equals mx plus b. Well, when we kind of talk about more pieces in our equation that we're given, this x and this y here represent a certain coordinate point. So in this case, we are given the coordinate point 3, 1. So I can plug 3, 1 into my x and y. So again, we start with x, y. So then if I were to actually write my equation out with all of my pieces filled in, I would start with my y, which in this case is my 1. And that will be equal to m, which in this case is 4. And now I want to plug in my value for x, which is 3. And then I'm trying to figure out what my b is. So I'm going to leave that as a variable because it's our unknown in this situation. From here, I can solve this like a normal equation. So I have 1 is equal to 4 times 3 is equal to 12 plus b, because I'm just going to drop that piece down since we're trying to figure it out. Then I'm going to subtract 12 on both sides. 1 minus 12 will give me negative 11, and then all I have on the right is equals b. So now I have a b that I can actually plug in. So all in all, this equation will end up being y equals, my slope is 4, x minus 11. And that's how I can find the slope of a line and the equation of a line based off of a given slope and a single point. So now I'm just going to practice this skill a few more times with different values. So I'm going to write my equation off to the side just so we always have that to reference. I'm going to plug in my x and y. So in this case, when I plug in y, I'll start with a 7 is equal to, my slope is negative 3, and the x value I'm given is 2 plus b. So then I'm left with 7 equals negative 6 plus b. I'm going to add 6 to both sides, which leaves me 13 equals b. So now to write the final equation of my line, I'm left with y equals negative 3x plus 13. So with that, all that we have left is number 3. So we have one last example that we're going to go through before we actually start talking about the graph itself. So here's our last one for this moment. We have number 3, which gives us the coordinate point 4, 3 with a slope of negative 5. So again here, I'm just going to plug and chug like I have been doing. So my y is given to me as 3 equals our slope, which is negative 5. I'm going to plug in my x, which is 4, plus b. Again, b is my unknown. That's a value I want to find out. And this is how I can find it out using equations. So then I'm left with 3 equals negative 20 plus b. So I'm going to add 20 to both sides, which will give me 23 is equal to b. So the equation of this line is equal to y equals negative 5x plus 23. Now we're going to jump to number 4. So in exercises 4 through 9, we are going to write an equation in slope-intercept form from the line that we're given. So here we can see that I have the graph with the points 2, 2, and 4, negative 1. So there are 2 different ways we can go about this. We're going to start with the graph. The first thing that I'm going to do is make a slope triangle because I can write that right in on the graph. So I move 1 unit, 2 units over, and then up. 1, 2, 3. So I have moved up 3 units, and I have moved over 2. One thing to notice with my rise over run is as I moved from left to right on this graph, my graph is going down, which means I will be having a negative slope. So I'm going to start with my negative, and my rise over run is 3 over 2. So in this case, my slope is equal to negative 1.5. Then, to find my y-intercept, I'm just going to find where's my y-axis. Oh, hey, it's right here. So now I want to find where does this line cross the y. And it looks to be about right. See if I can get it to work for me now. right here. And if I were to look at my graph, it looks like my graph is going up by 1s. So it looks like that's at 5. So my y-intercept is 5. So based off of that information, I can put my pieces in my equation to give me y equals negative 1.5x plus 5. Now, to show you that these two things are going to mean the same thing, we're also going to find it algebraically. So I have 2 points here. Again, 4 comma negative 1 and 2 comma 2. When I'm told to find the equation of a line and all I'm given is 2 points, we're going to pretend like the rest of the graph doesn't exist for right now. So 4 comma negative 1 and then 2 comma 2. First, I need to find the slope between these 2 points. Again, we're going to pretend that I didn't do the slope triangle, so we have no idea what the slope is going to be. M is equal to y2 minus y1 over x2 minus x1. So if I plug those pieces in, my y2 is going to be this 2 here. Then I'm going to subtract my negative 1. And that is going to be over my x's, which is, again, I'm going to start with 2. Since I started with 2 comma 2 on the top, I have to start with that point on the bottom. I have to make sure that I stay consistent. And then I'm going to subtract 4. So simplifying this, because I have 2 negatives here, I'm going to cancel them, make it positive since I'm subtracting. So 2 plus 1 gives me 3. And then 2 minus 4 gives me a negative 2. What do you know? I am still left with negative 1.5. Now we're going to use one of those coordinate points to plug in so I can find my b algebraically. So we're going to use 2 comma 2. So I'm going to start with 2 equals. My slope I found was negative 1.5. I'm going to plug in another 2 in, since both of these numbers are 2, plus b. So then when I solve algebraically, I'm left with 2 equals negative 3 plus b. So I'm going to add 3 to both sides, which means that 5 is equal to b. So again, I'm given the same equation of y equals negative 1.5 x plus 5. So for this one problem, we used 2 different ways to find the exact same information. Sometimes you'll be given the graph and you can kind of plot it out and figure it out. Other times, like in 1 through 3, we're going to be given a point and the slope. Sometimes we'll be given 2 points, and we have to know which method to use based off of the information that we're given. So with that, now we can move over to number 5. I'm going to start number 5 by just guesstimating. So I can see that my y-intercept is about here. When I look at this point, it's going to be a little bit over the number 1. So I don't exactly know what my y-intercept is going to be. I just know it's going to be greater than 1. When I use my slope triangle, I'm going to make sure that I connect my points. So then when I count up and down, I'm giving 2 units. When I count to the right, I'm left with 8. So then based off that, my rise in this case is a negative 2, since I have to go down to find my second point. And my run would be 8, which gives me a negative 1/4. Or if you prefer to use decimals, negative 0.25. So in this case, I'm going to jump straight to plugging in x and y to find my b. So in this case, we'll use 5 comma 0. My 0, or my y, is 0. It's equal to My slope in this case is negative 1/4. My x is going to be 5. And then plus b, that's what I want to find out. So now from here, I can simplify. 0 equals negative 1.25 plus b. I'm going to add 1.25 on both sides. So I'm left with 1.25 equals b. So now I have both of the pieces of my equation here and here. So the equation of my line is going to be y equals negative 1/4 x plus 5/4, or if you'd prefer to use 1.25, that is totally acceptable also. They both mean the same thing. Now let's move on to number 6. So I have negative 5, 3 and negative 2, 0. So for this one, I'm actually going to take the 2 points and plug it into our slope equation and find it algebraically. So this will be x1, y1. This will be x2, y2. So I'm going to have 3 minus 0 all over negative 2 minus negative 5. When I solve that, that will come out to be 3 all over. We have negative 2, which will become plus negative 5. Just kidding. I definitely saw my mistake here, so I'm just going to take some eraser here. So again, I made the mistake of not keeping my points consistent. Since I started with 3, I need to make sure that I start with negative 5. So negative 5 minus negative 2, which equals 3 all over negative 3, which gives me a slope of negative 1. So then I'm going to go ahead and plug in my points. So we're going to take negative 5, 3, which means we're left with 3 equals negative 1 times negative 5 plus b, which simplifies down to 3 equals 5 plus b. I'm going to make sure I subtract 2, 5 on both sides, minus 5. There's where my 2 comes in. Negative 2 equals b, which when we look at the graph, here is where our intersection point is, which again is at negative 1, negative 2. So then my equation is y equals negative x, because there's kind of an imaginary 1 in the front, minus 2. So again, then when we look at our slope triangles, I moved to the right 3 units, and I'm also moved down 3 units. So again, that checks out with our rise over run. And then we also have our graph showing that our line crosses the y-axis at negative 2, which again is also shown in our equation. Now on to number 7. We're going to take 5 minus 2 all over 9 minus 6, which gives us 3 over 3, which simplifies down to a positive 1, which we can see here by the fact that our graph is going up. So then I'm going to take the point 6, 2. We're going to take 2 is equal to 1 times 6 plus b, which gives me 2 is equal to 6 plus b, minus 6 on both sides, and I'm left with negative 4 equals b. And when we look at the graph, it looks like each line represents 2. So we have negative 2 here, which means this line here would be negative 4. So that lines up. Our equation is y equals x minus 4. So then, now that we move to number 8 and number 9, we move into our special lines that we have, which are both vertical and horizontal. When I look at number 8, I have 2 points noted. 3, negative 2, which is right here, and 3, positive 2, which is here. I'm also going to notate one more point, which is right on my x-axis, which will be 3, 0. So by looking at this graph, we know that our rise is just kind of keep going, but in this case, we don't have a run. So if we don't have a run, that would normally mean we divide by 0, and that's something that we cannot do as mathematicians. But we're going to pretend that we don't know that, and we're going to actually do the math to try and find the equation of our line. So we'll take 3, negative 2, and 3, 2. So we're going to start with negative 2 minus 2 all over 3 minus 3, which gives us negative 4 over 0. But again, we can't divide by 0. What we do know, we don't have a slope, but if we look at where x equals 3, as we see the graph go up and down, it doesn't matter what our y value is, because our line just is going to keep traveling up and down regardless. But we do have a point of intersection where our line meets the x-axis, which again is at 3. So when we write the equation of our line, we're just going to leave it as x equals 3. There's really nothing else that we can say about it except, hey, we have a line traveling through this point, and it's just going to keep going and pretty much kind of do what it wants here. In number 9, we have more of a rise over run situation we can work with a little better. Since we're moving to the left and right forever, we have no idea what our run is. But when we think about our rise, we don't change as the line travels to the right. So that means our rise in this case would be 0. But we know that 0 divided by anything ever will always be 0. So because of that, I have y equals. And we know that my slope is 0, so 0x. My graph starts at the point 3. We talked last time that if we have 0x, it's really not necessary to keep in our equation because it doesn't change anything. So we're just going to leave this as y equals 3. Now, I believe this should all be on page 10, so we're actually almost done. We are told to graph the equation of a line, which in this case is y equals negative 2/3 x plus 5. Well, we know our slope in this case is m, which is always in front of the x. So in this case, our slope is going to be negative 2/3. So I'm going to go ahead and write that in negative 2/3. And this is slope-intercept form, which means that this other number here, my 5, is my y-intercept. So I'm going to make sure to add that in. Once I've identified the slope and y-intercept, these points here are points that I found by plugging x into my equation, and this is the y that popped out. If you look at the graph, we have 3 different points. I'm going to attempt to draw a line between them, and we'll call that good enough. So here we can draw a graph just by creating some points and making sure we plot them, and then creating a line. So then when we look at number 2, we have graph x equals 4. Well, if we have x equals negative 4, we don't even have a slope to begin with. One thing that we really want to pay attention to is that it says x equals here. So if it's x equals, we have to make sure we look at the x-axis. So we want to find negative 4 on our graph, which is about here. So then my line is just going to run along where x is 4. So we don't have y-intercept because, again, y doesn't matter in this case. We're just going to have a line run vertically, up and down, through the point x equals negative 4. So because we're on the subject of special lines, I'm frankly going to jump to number 4 right away, since that one will be a quick one. Again, we don't have a slope in this situation, so I'm going to cross that out because we don't have one. Now we have a y equals. So in this case, our slope would be 0 because it doesn't exist. So that means we're left with a positive 6, which means our y-intercept in this case will be 6. So when I count up 1, 2, 3, 4, 5, 6 spots, it's about right here. I'm going to have a line that runs horizontally. Since we have y equals 6, in this case, x doesn't matter. We're going to have y equals 6 when x is equal to 1, when x is equal to 5, when x is equal to -3, you name it, it doesn't matter. So now, the last one, bouncing to number 3, I have some points listed here, and these points came from the fact that I plugged this 0 in to x in our equation. 1/2 times 0 gives us 0. So we take 0 and subtract 3. We're left with, -3. So based on the equation, we know that our y-intercept here can be -3, and our slope is a positive 1/2. So in this case, our graph is going to travel up and to the right. So now I've added in the points that are listed here, and I've plotted them, connected them, so we can see that our graph is traveling up pretty slowly in this case. We're only going up by 1/2 every increment, but we'll get there eventually. So this lesson had talked about how to use slope-intercept form. How do we make slope-intercept form? How do we take a point and a slope and make it into something more? And how do we look at a graph? And how do those two things compare together? Feel free to rewatch this video if you absolutely need to. The next thing that you are going to do is you're going to move into Desmos. And your link for Desmos should be in Schoology. It should be coin catchers. So you'll want to go through this Desmos activity. I will be checking for it when I return. If you have any questions, feel free to reach out and we can talk about it more. Have a wonderful day.